Over the past 10 plus years of writing code professionally, I can see that I've grown a lot with regards to my code proficiency and how I manage my code. As I've gotten more experience in coding and hearing some feedback from my coworkers, I'm starting to see a lot of trends and a lot of themes when it comes to managing code well. If you can manage your code well, you can save yourself a lot of time and save yourself from a lot of headaches. And that's because if you don't manage your code well, it's easy for a lot of bugs to creep in, and it will take a lot of time to debug those bugs. But if you manage your code well, you can have a good structure for how you start developing your code, and you will develop a lot of good practices which can save you a lot of time in the long run. In this video, I've come up with 7 tips that really changed my career and helped me manage my code a lot better. And these 7 tips are things that I look at when I look at new programmers' code. Whenever I see something wrong with their code, it usually relates to one of these 7 tips. So I really hope as I share these 7 tips to you, it really changed your career as well. So let's discuss. By the way, if you're in the early stages of your programming journey, I've got a special gift for you. It's called my 30-day beginner coding challenge. And it's a guide that will take you from no coding experience to building your first 4 projects. And the best part is it's free. It's a free gift to you. In this coding challenge, I guide you in 30 days to build 4 programming projects, and I give you some tutorials that are in C. But of course, these projects are really generic and really beginner friendly, and so you can actually code them in different programming languages. You can still benefit from this guide because you can just take the principles that are in my challenge and then apply them to your programming language. You can find the challenge in the link in the description, and if you download it and pay attention to what it says, you'll definitely learn some fundamental programming concepts that will give you a good foundation to your software development journey. Alright, the first tip is to use version control. If you're not using it already, I recommend that you use Git as you develop your code. Version control is really key because it allows you to save different versions of your code. And so when you have code that is working really well, you want to be able to save it and cement it somewhere. That way, if you mess up your program later on down the road, you can revert back to that version that you know was working. Having version control at my company saved us a lot of time. A lot of times something in our code would break and we wouldn't know what was causing it. So what we did was we would just go back to certain commits that we knew that the feature was working in. And then that way we can look at the version where the feature works and compare it to the version where the feature doesn't work. And then we can see what the differences are, and it'll give us a clue on what's causing our feature to break. Usually when you're using version control, you want to have a new version every time something significant has changed in your program. If you've developed a new feature or you've fixed some sort of bug, you want to have a new version for that change. A lot of times with new developers, I've seen them use commits where they have a bunch of changes that they've made in the past 3 weeks. They put that all in one commit. And I don't think that's a good idea, because if you do it like that, and then if you have something messed up in your code, you don't know which part in that commit is causing the issue. But if you separate it out into individual commits, you can really narrow down which commit the feature is working versus which commits are where the feature is not working. If you want to dive deeper on how to use Git like a professional, you can watch my other video on how to use Git like a professional. And that leads to my second tip, which is to build your code incrementally. I always remember this story that my professor gave. He was talking about how one of his students just sat down in class one day and he coded our whole project in one sitting. And then after he's finished coding, he just compiled it and then ran it, and then no surprise, the code didn't work. And my professor was really highlighting how you need to break down the project into individual steps. If you can break your program into individual steps, you can just focus on those individual steps first. Focus on getting one individual step working, and then when that's working, build the next thing. And then when that's working, add some more feature, more capability to your program, etc., etc. Start with something simple first, get that working, and then when it's working, make it more and more complex. Git is a really useful tool because if you build your code incrementally, when you have that first step working, you can make a version of that code. And then when you have the second step working, you can make another version of that code, etc., etc. Alright, the third tip that really helped me is to get rid of code redundancy. For example, if you have a program and it runs a certain algorithm multiple times within that program, you may want to create a function for that certain algorithm. Say you have an algorithm that takes 8 lines of code to run, and you want to run it in the beginning of the program, in the middle, and at the end. You don't want to have those same 8 lines of code in the beginning, in the middle, and the end. You want to create a function so that all you have to do is call that function those 3 times. Or another example is if you have some if and else conditions and you have some lines of code in the if case that are also in the else case, you want to just remove those lines of code from the if and else blocks and just bring it outside, because whether or not you go in the if or else statement, you're going to run those lines of code anyway. So just take them out of those 2 blocks of code. Here's an example of code redundancy that I got from ChatGPT. Say there's a function to check if a number is positive. You put the number here and it'll check if it's positive. If it's positive, it'll return 1. And then there's another function that checks if it's negative. If it's negative, it's going to return 1. And then say you have the number 5 and then you call is positive, it will return 1. And then if it's -3 is the number, then you call is negative and then it will also return 1. So let's run this program. So as expected, 5 is positive, so it returns 1. -3 is negative, so it returns 1. So one way that you can reduce your number of lines of code is to just combine these 2 functions together, the is positive and the is negative, because they're both checking the number if it's greater or less than 0. And then you can just return a certain number if it's positive and a certain number if it's negative. So here we have a new function that's called check sign. So if it's positive, it's going to return the word positive. If it's negative, it's going to return the word negative. If it's 0, it's going to return 0. And then all you have to do is, if it's 5, you put 5 in here, and then you have the result in here. So it's just going to say 5 is positive, and then here it's going to use the same function, and then it's just going to return negative. So -3 is negative. So let's run that. And there you go. 5 is positive, -3 is negative. So basically you get the same output that you want, but you achieve it in only one function. So you reduce the amount of lines of code that you're using. Alright, the 4th tip is to improve the code readability. You want your code to be readily understandable if someone's looking at your code, because you're not the only one who's going to be looking at your code. It's going to be your coworkers, it's going to be your team. They're going to look at your code, and if it's hard for them to understand what's going on, then that's because you're not good at coding. You're not good at managing your code. And also, say in the future you want to look at your code, maybe it's been 3 months. There's been many times I've looked at my code that I wrote 3 months ago, and because I have good code readability, I understand what's going on right away. But if you have bad code readability, it will take you some time to figure out what's going on, and that can waste a lot of time. Alright, so here's an example of bad code readability. So you have this function VWLC, and see, you don't even know what it is because the name of the function is a bad name, and that's because your code is not readable. So this function, what it does, it returns the number of vowels of a string that you give it. So you enter the string here, it scans it in, and then you put that into the function, and it will return the number of vowels. So let's try it. So let's put in my name, and there's 2 vowels, and then there you go. So it actually works, but it's hard to understand what's going on. And look at this for loop. It's all contained within one line. So you have the I, and then, I mean, that part is easy to understand, but then just look at it. It's hard. You have to scroll sideways to see what's going on. And then you can see the A, E, I, O, U, and then the capitals, and then V++, and then you return V, but you don't know what V is. So you actually have to run the code to figure out what's going on. But there's a better way to make this more readable. Alright, here you go. This is a lot better. So now the function is not called VWLC or whatever. Now it's count vowels, and that makes a lot of sense. You can readily understand what that function is doing. It's going to count the vowels of a certain string. And then the for loop is not all in one line. It's indented really well, and then it has the curly braces so in such a way that it's easy to understand where the for loop starts and where it ends. And then you have the if condition here, and all of the different conditions in the if condition is readily available. It's readily seen. You can see the A, E, I, O, U, and then also it's using the variable name current char, and then it's using the variable vowel count. So vowel count is the one that's incremented instead of some random variable called V. So you can just look at this code and you can see, oh, current char is, they're doing a for loop on the characters in the string, and then if the current char is A or E, I, O, U, then I'm going to increment this vowel count, and that's readily understandable. And then likewise in the main function, you separate out the declaration of the variables here, and then the instructions to the user, and then the actual function call, and then your feedback to the user. So it makes your code look a lot better. Alright, the fifth tip I have for you is to come up with test cases and make sure you're handling each of the test cases. In one of my previous videos, I talked about how a common interview question or a favorite interview question of many interviewers for an interviewee is to ask the interviewee to code the power function. And the reason why the interviewer wants to see how you code the power function is partly because they want to see if you understand all the different test cases that can happen. They want to see if you're thinking about these different test cases and if you're able to handle them as you're developing this function. When the interviewer gives you the question, they might say that this function pow, it would just do pow, and then the two arguments are 2 and 3, and then it should return 8, and then that's the only test case that they give you. But they want to see if you're smart enough to come up with your own test cases. They want to know if you're going to think about the case 0, where for any exponent, if it's to the power 0, it should always equal 1. They want to see if you come up with the exponent 1 case, so that's another test case. So that's another test case, pow 2, 1, and that should always equal the base number, which is 2. And then they want to see if you can handle potential exponents that are negative. So pow 2, -3, that should equal 1/8. And they want to see if you think about that when you're coding this function. Coming up with test cases is really important, because if you don't come up with those test cases beforehand, you can be so stuck on the default case, and then you're just thinking about getting the default case to work, and then you don't handle any edge cases or corner cases that may happen, and then later on down the road your code will break because those edge cases or corner cases happen, and then it's going to be a headache, and then you have to spend time to handle those different cases. But if you had come up with test cases beforehand and then you handled them right away, then you're not going to ever have to come back to those cases ever again. Alright, tip number 6 for you is you need to document your code. And there's two main ways that you can document your code. You can either put a lot of comments in your code. Some people may not think this has got documentation, but it really helps a lot, especially if you look at your code in the future. When you're looking at your code that you wrote a year ago, those comments that you're writing, maybe you write the description of a function, or maybe you write down the return values of the function and what they're doing. If you have that in your code and you're looking at your code, that can save you a lot of time, because you're not spending time trying to remember what you coded in the past. Now, the proper way to document your code is to have an actual document, and then in this document you can lay down all of the different functions that you have, any sort of protocols that your code is using, and any sort of algorithms that your code is using. It'll be helpful for someone in the future who's looking at your code, that they don't have to try to understand what your code is doing by looking at the code. They can just read the documentation, and when they read the documentation, it's like you're right there next to them explaining how your code works. And this may not seem important if your code is really simple, but if you have more and more complex code and you have some features that took you a couple months to implement, then it's really good to have this documentation so that it can be referred to later on. Alright, my 7th and final tip is to always ask for feedback. That's probably the best way that I've gotten better at coding. So what you want to do is look for someone who's better than you, or someone who's at the same level as you, and before you start your code, before you build your program, you want to lay out to them, you want to explain to them how you plan on implementing your code, how you plan on managing your code. You can say, hey, this is how I'm planning to write my code, this is how I'm planning to implement this algorithm. What do you think? Do you think that that's a good way of implementing it? Or do you think there's a better way of implementing it? That will save you a lot of time, and it will give you some ideas that, especially if you're new at programming, it'll give you some ideas that you haven't thought of. And then when you have those different ideas, you can weigh the ideas out, and then whichever one is better, you can go down that path and implement your code that way. And then when you're done writing your code and you've implemented it, and you've implemented the best that you can, and if you were to look back, there's nothing that you can improve on, then that's when you ask that person to look at your code and do a code review. Then you have a fresh pair of eyes looking at your code. They can point out anything that's potentially dangerous to have in your code, and then they can point out some bad practices too. And this is the main way I developed my code in the past. I would ask a more senior developer what they think about my approach, and then after we talk about it, then I go implement it, and then I do a code review and see what they think of how I implemented it. Say you're by yourself, you don't know anyone else who's coding, it's just you, and you want to learn how to code on your own, be self-taught. You can always go on the internet. On the internet, there's a lot of people, there's a lot of communities of people who are trying to get better at programming. You can check on Reddit, there's the subreddit Learn Programming, And there's some subreddits too where you can also find other developers who are trying to code in the language you're trying to code in, and then you can try to make some friends there and try to work on a project together. When I was at my company, Reddit wasn't really a popular place to learn how to code. It was usually Stack Overflow, or people would be asking questions and those questions would be answered on Stack Overflow. And a lot of times I would have a question or I would have an idea on how to implement something, and I would just look it up on Google, and then there would always be a Stack Overflow question that answers my question or that has a question that is similar to what I'm thinking about. So if you can't find someone in person that you know that you can ask feedback from, you can just go online, type up the thing that you're trying to implement, the idea that you have, see if other people have tried it, and then see what the forums and all the articles say about it. And you can also ask me. You can just email me or leave a comment down below and talk about the idea that you have, and then I'll try to answer you there. Alright, so those are the 7 tips that really changed my career and helped me become more proficient at programming and manage my code better. The first one is to use version control, particularly Git. The second one is to build incrementally and use Git as you build incrementally. The third one is to get rid of code redundancy. And the fourth one is to improve code readability. The fifth one is to come up with some test cases and make sure you handle them. Sixth one is documentation, make sure you document your code. And the seventh one is to get some feedback on your code. Alright, what about you? Which one of these 7 really stuck out to you? Which one of these 7 do you really need to start implementing now or start to keep in mind more often? I think if you keep all of these 7 in mind, you will really manage your code a lot better and develop a lot more cleaner code. Alright, like I mentioned earlier, if you're just starting off in your programming journey and you don't know where to start, you can download my 30-day beginner coding challenge. And it's a 30-day guide where I teach you how to build those 4 beginner programming projects. It's really beginner friendly, and I go step by step on how to build each one and go through the tutorials that you need to build each one. So download that in the link in the description. Alright, that's it for this week's video. I hope it really helped you out. And if it did, please like, share, and subscribe to the channel. I'd really appreciate that. And if you have any other questions, feel free to let me know in the comment section, and I'll be sure to answer you there. And I'm Henrik M, and I'll see you in the next one. Peace.